this video, we are going to learn how to solve a quadratic equation using delta. First, let's recall the quadratic equation. The quadratic equation is in the form of ax squared plus bx plus c equal 0, where a is not equal to 0. Let's now introduce something new for you, which is called the discriminant, and we name it delta equal b squared minus 4ac. What do we mean by b squared minus 4ac? b is the number here, the coefficient of x, a is the coefficient of x squared, and c is the number. Now, we want to find delta, which is b squared minus 4ac. This quantity will be a number. Before moving on in this explanation, let's make a practice on how we calculate the discriminant. We have equation 2, 3. In order to find the discriminant, we have to first detect a, b, and c correctly, because once you know how to find a, b, and c very well, of course delta will be correct with you. Let's now start with the first equation. A is equal to 2, b equal minus 3, and c equal to 1. In the second equation, a equal 8, b equal to 2, and c equal to 0. As we saw in the previous video, when we don't have here anything, we can say we have plus 0. So c here is equal to 0. Third equation, a equal minus 7, b equal 3, and c equal minus 2. So now we learned how we can find a, b, and c. Now let's find the discriminants. The first equation, delta equal b squared minus 4ac. So delta equal b squared, which is minus 3 squared, minus 4ac, minus 4 times 2 times 1. The answer is 1. So the discriminant of the first equation is equal to 1. Now the second equation, delta equal b squared minus 4ac. So it's equal to 2 squared minus 4 times 8 times 0, it's equal to 4. So here delta is equal to 4. The last one, delta equal b squared minus 4ac. So it's 3 squared minus 4 times minus 7 times minus 2, which is equal to minus 47. Okay. Now, how does delta help us to solve a quadratic equation? And this is the purpose of this video. As we saw that delta, the discriminant, it's called b squared minus 4ac, which is a number. So this number can be positive, negative, and 0. So we are going to classify it into 3 categories. So delta, if it's positive, what will happen? If it's negative, what does this mean? And if it's 0, what can we do? Case 1. If delta is positive, there are 2 distinct roots. What are these 2 distinct roots? The first root is minus b plus radical delta, and delta is the b squared minus 4ac over 2a. And the second root is minus b minus radical b squared minus 4ac over 2a. Of course, you are not going to recalculate b squared minus 4ac, you are just directly write the answer from delta. And don't forget, now we are in case 1 where delta is positive. So when delta is positive, b squared minus 4ac is positive, so the quantity inside the radical is accepted. Let's understand it more graphically. When delta is positive, we said that there we have 2 distinct roots. What does this mean? In the coming lessons, inshallah, we are going to learn the functions and to graph it and to understand it very well. But now we can have a quick look about it. When we have root, it means that the function cuts the x-axis. This is the function, the green one. This one is, all of this one is the graph, the curve, the function, the quadratic function. So when we say we have roots, it means that it cuts the x-axis. It cuts it in A and in B. So these are the 2 roots. In this example, delta is equal 43.05, which is a positive number. So we have here 2 roots. Also, this one another example of a quadratic function that has delta positive 78.41. Regarding less how we calculated it here, we have to know only that it's positive delta. So we have two distinct roots. We have 2 points of intersection of the curve with the x-axis, A and B. So case 1, if delta is positive, we have two distinct roots. Now if delta is negative, no real roots. We don't have any real roots. Graphically, the curve here, as you can see, doesn't make any intersection with the x-axis. So there are no real roots. That's why delta is negative in the first example. And in the second example, delta is also negative. So as you can see, the curve here, the green curve, doesn't intersect the x-axis. So there is no point of intersection with the curve and the x-axis. So we don't have any real roots. So when delta is negative, no real roots because there is no intersection between the curve and the x-axis. Now case 3, if delta is 0, there is a double root. What do we mean by the double root? We mean that x prime equal x double prime equal minus b over 2a. What do we mean by double root? As you can see here, the curve will be tangent to the x-axis. So here we have a double root, as if a and b are here, but here at this case, a and b are coincided on the same point. And the second one here, the quadratic function, also it's tangent to the x-axis. At this point, we say that we have a double root. Now we are going to talk about the reduced discriminant. What is the reduced discriminant? It's the first is discriminant, so it has the same task as the discriminant, the delta, but it's reduced because sometimes we have a big numbers. So in order to facilitate our calculation, we may use the delta prime. It's not obligatory, but you can use it to help you for easier simplifications. Actually, delta prime, is used simpler when b is even. Why when b is even? Because when b is even, it means that we can write b in the form of 2b prime. So there is something b prime where 2 times b prime is equal to b. So the delta prime is equal b prime square minus ac. It's similar to delta, but it is reduced. As you can see, there is no b square, there is no 4 here. So we square b prime, which is half of b, and we subtract with ac only. So it's a reduced number. Also in the reduced discriminant, we have cases. If delta prime is negative, we have no real roots, the same as delta. So if delta prime is negative, we have no real roots. If delta is negative, no real roots, the same thing. If delta prime equal 0, we have a double root here. But the rule here, x prime equal x double prime equal minus b over a. If delta prime is positive, we have two distinct roots. The two distinct roots are x prime equal minus b prime plus radical delta prime over a, and x double prime equal minus b prime minus radical delta prime over a. So these rules are to be memorized very well. Now let's make solved exercises. 2x squared minus 3x plus 5 equal 0. So let's find first delta. Delta is equal minus 3 squared minus 4 times 2 times 5, which is b squared minus 4ac. It's 9 minus 40, which is minus 31. So we get delta is negative. Once delta is negative, you directly say no real roots. Second example, 3x squared minus 2x minus 1 equal to 0. So here delta is b squared minus 4ac, which is 4 plus 12, which is 16. 16 is positive. It means that we have two distinct roots. X prime equal minus b plus radical delta over 2a and minus b minus radical delta over 2a. So it's 2 plus radical 16 over 2 times 3, which is 1, and 2 minus radical 16 over 2 times 3, which is minus 1 over 3. And this one, I'm going to solve it another way using the reduced discriminant, because b here is even, so let's make delta prime. What is b prime? B prime is half of b. So it's minus 2 over 2, it's minus 1. So now delta prime is b prime square minus ac, so it's 1 plus 3 equal 4. It's positive, so we have two distinct roots. The two distinct roots are minus b prime plus radical delta prime over a and minus b prime minus radical delta prime over a. So it's 1 plus radical 4 over 3, which is 1, and 1 minus radical 4 over 3, which is minus 1 over 3. As you can see, the same as the previous results, but it's reduced. You as a student, you can choose any thing you like. If you like delta, you can use delta. If you like delta prime, you can use delta prime. So here in this case, delta prime is easier because the number b is even. X squared minus 6x plus 9 equal to 0. So delta here equal minus 6 squared minus 4 times 1 times 9, which is equal to 0. So here we have a double root, x prime equal x double prime equal minus b over 2a. Now we have some remarks you have to take into consideration. If a plus b plus c equal to 0, so you can directly, without finding any delta, without doing anything, you can directly say you have two roots, x prime equal to 1 and x double prime equal c over a. Example, if 2x squared plus 3x minus 5 equal to 0, because a 2 and b 3 and c minus 5, if you add them you get 0, then directly say x prime equal to 1 and x double prime equal minus 5 over 2 without using delta. But if you didn't notice this remark, you can simply find delta and you will get the same results. The second remark, if a minus b plus c equal to 0, then x prime equal to minus 1 and x double prime equal minus c over a. Some students like this form, a minus b plus c equal to 0. Some students don't like this one, so we can say instead of a minus b plus c, we can say b equal a plus c. So either you say b equal a plus c or a minus b plus c equal to 0. So if you have this case, directly you can say x prime equal minus 1 and x double prime equal minus c over a. Example, 5x squared minus 2x minus 7 equal to 0. We have here 5 minus 2, which is plus 2, plus c, which is minus 7. The answer is 0. So directly x prime equal minus 1 and x double prime equal minus c over a, yani minus 7 over 5, so it's 7 over 5. Now it's time for practice. You can pause the video and try to solve these 4 examples about quadratic equation. You can use delta, delta prime, or any of the remarks, and when you finish, play the video to check out your answers. Now it's time to check your work. These are the equations and their answers.